a single grain of sand, holds the potential to store an entire library of information. This phenomenon occurs when we consider the vast storage capacity of the human brain. Scientists have discovered that our brains can store up to 100 terabytes of data. To put that into perspective, the entire printed collection of the Library of Congress holds about 10 terabytes of data. But that's not the strangest part. Our brains also have the ability to retrieve information at an incredible rate. Imagine being able to recall an entire conversation or a complex mathematical equation with perfect clarity. It's like having access to an infinite knowledge base that's readily available at all times. But what happens when we try to store this information digitally? The answer lies in the world of quantum computing and the principles of quantum mechanics. At its core, quantum computing is based on the idea that information can exist in multiple states simultaneously. This means that a single qubit, the basic unit of quantum information, can hold both 0 and 1 at the same time. But that's not all. Qubits can also exist in a superposition of states, allowing for exponentially faster processing times. It's like having a computer that can process an entire library of information in a matter of seconds. But how does this work in practice? One way to think about it is to imagine a vast network of interconnected nodes. Each node represents a single piece of information, and the connections between nodes represent the relationships between those pieces of information. When we input a query into the system, it's like sending a message through this network. The message propagates through the network, bouncing off nodes and creating a complex pattern of interactions. It's a bit like watching a wave crash against the shore. The wave represents the query, and the shore represents the information we're trying to retrieve. As the wave crashes, it creates a unique pattern of water and sand that's unlike anything else on the beach. Similarly, the interactions between nodes in the quantum network create a unique pattern of information that's unlike anything else in the system. And that's not the strangest part. This network can also exist in a state of superposition, allowing for exponentially faster processing times. But what does this mean in real-world terms? Imagine being able to access an entire library of information in a matter of seconds. Imagine being able to solve complex mathematical equations with perfect clarity. Imagine being able to communicate with people across the globe in real time. It's a future that's both exhilarating and terrifying, and it's one that's rapidly becoming a reality. As we continue to push the boundaries of what's possible with quantum computing, we're unlocking new possibilities for human innovation and progress. And it all starts with a single grain of sand, or rather, a single qubit. So if you're fascinated by the possibilities of quantum computing, be sure to subscribe for more exciting content like this. And let me know in the comments what you think is the most exciting potential application of quantum computing. Want to explore more mind-blowing facts? Hit subscribe and join our journey of discovery. If you found this fascinating, subscribe for more incredible stories like this.